All right, class. So in this podcast, we're going to basically just look at the calculation side of calorimetry. So there was a podcast just on notes and kind of just had the background, and now we're going to use that information to actually solve some problems. So calorimetry has to deal with the idea that the amount of energy lost by one thing is equal to the amount of energy gained by something else. So really we have positive Q equals negative Q. And one of these Q's is system, one's surroundings. Every problem you're going to do for calorimetry is going to have a piece of metal and some water. So for me, I'm just going to always put the metal on the left-hand side, just so I always do the same thing, and I'm going to have water on the right-hand side. Okay? So really, Q doesn't do us much good, but based on our previous podcast, we know that Q equals MC delta T. So in this first problem, it says if 45.6 grams of aluminum, okay, so that is the M of my metal, so 45.6 grams, at 128 degrees is placed in a beaker of water, and the water's temperature changes from 18.8 degrees to 30.2 degrees. What is the mass of the water? The specific heat of water is 4.184 joules per gram degree Celsius, and the specific heat of the metal is 0.387. All right, so I basically have M, and I'm going to multiply that by C of metal, which is 0.387. And I'm going to multiply that by my change in temperature, which is delta T. So again, I'll just put this equation up here. Q equals M C delta T. And delta is always final minus initial. So if we look, we see that the final temperature of our water is 30.2, and that's also going to be the final temperature of my metal because of thermal equilibrium. So if we place two substances, whether they're metals or whatever, next to each other, and they're different temperatures, their final temperature is going to be the same thing. Okay? So that's one side of my equation. That's just the water side. And that's going to equal, and here is important, don't forget the negative. If you forget the negative, you'll get the wrong answer. Okay? So the mass of my water is my X. That's what I'm trying to determine. The specific heat of my water is 4.184 joules per gram degree Celsius. And then lastly, the change in temperature of my metal is going to be finally 30.2 minus 18.8. Alright, so now we're just solving that. So I'm going to pull up a calculator, and I'm just going to multiply the left side. So 40.6, actually I'll do the subtraction first. 30.2 minus 128.1. I'm going to multiply that by 0.387, and I'm also going to multiply that by 45.6. We get negative 1727.7. So negative 17. Whoa. Where's that? So 17. 27.7. And that's going to equal, on this side, negative. And I'm just going to take 30.2 minus 18.8. And I'm going to multiply that by 4.184. And I get 47.70 x. Alright, so I'm going to solve for x. I'm going to divide both sides by negative 47.7. We're going to find that x equals, so I have 1727.7 divided by 47.7, and negative divided by negative is just positive. So I get 36.2. That's my answer. And again, I'm being asked for mass, so the mass of water. Alright, so that's how we do the top one. Expect a question like that on the quiz, expect a question like that on the test. The other one is a little bit different, and if we read this one, we see when 33.4 grams of an unknown metal at 111.5 degrees is placed in 127 grams of water at 20.3 degrees, the final temperature of the water is 28.8. What is the specific heat of the metal? Alright, so same idea. We're going to take mass of metal, so in this case 33.4 grams, and we're going to multiply that by X. That's our unknown this time. What's the specific heat of the metal? And then my final temperature is going to be 28.8 minus 111.5. So that's the change in temperature of my metal. And that's going to equal negative, right? We know the mass of the metal, or the water this time, 127.9. Specific heat of water is always the same, 4.184. Woo, that's crazy, 8. And then we have final temperature minus initial, which is going to be 28.8 minus 20.3. And again, we're going to do this math with the calculator. So on the left, I have 28.8 minus 111.5 times 33.4, basically negative 27.62, negative 2762.2x, because x is now on the left, equals, and let me run this over real quick. We have 28.8 minus 20.3 times 4.184 times 127.9, so negative 4548.6. Negative 4548.6. And we're going to divide both sides by negative 2762. And we find that x equals divided by 1.65. And it's specific heat capacity this time, so I have units of joules over grams degree Celsius. Whoa, crazy C. Alright, so anyways, that is how we do problems. Again, expect one like that on the test, one like that on the quiz, and essentially what your lab is, you'll have a lab like this. It's just like the second one. That'll be a lab we do this week. So anyways, that's it.